Hey guys, here's how to do a fairly simple I/O map in Sysmac and how to automatically load up your CPU rack. So I'm just going to start from a blank project. I have an NX102. Great. Well, first thing you want to do is always set up your communications using a hub. The default IP for the NX102 is 250.1. We'll test it. You got to make sure you're on 250. All right, worked that time. Okay. So on my CPU rack, I have an input card, an output card, and then a power supply card. So you can manually find your devices, drag them over, and then you can add the cards that way. But the better way, if you're all set up, just go online with your CPU, right-click, compare and merge. It'll say that that's what I have. This is what it actually is. We can apply it. Hit OK. And then this is our actual device. So we have a PF0730, which is the I/O power supply. Then an input unit and an output unit. So then we'll go back offline for development. To set up your I/O map, if you open the I/O map on the left here, open your bus master, then we have our output card, 16 output bits, input card, 8 input bits. So a couple ways you can create your I/O map is just do it right from the window here. I like to prefix all inputs with I underscore and then all caps. So this you can do like, button 1, obviously a horrible name, but do what you need. Button 2, you could create them that way. What this does is creates global variables. So data, global variables, we can see these are the two we just created, and it assigns them an address of the card and the bit. If you press the insert key, you can also create variables here. We can do, button 3. It is not assigned yet, so we need to go to the I/O map, and you can bring it up from this dropdown along with any others you've created and assign them. And then it creates it, and if you go here, it assigns it. And outputs work the same way. So we can do, whole solenoid 1, whole solenoid 2. So that's kind of how you do the I/O map. Then just for basic, how to use it in a program, we can do a pretty simple, pick your button, do your solenoid. If we go online, download to controller, execute, it'll do its thing. This is yellow, by the way, because we haven't applied the changes. So if you're not seeing this green and yellow, if you click the eyeglasses up here, it turns the live view on and off. And it'll appear yellow if the changes in your program do not reflect the changes on the CPU. Or if you have an error in your code, it can be yellow, like a runtime error. I have a physical button tied to my button 1, so if I press it, I'm pressing it now, we can see the live view, it's doing its thing, release it, and it's off. A couple tips on how to, this is not great syntax here. What I like to do in a program is rather than do, like you might want to turn this on from multiple spots in your program. So for like global I/O, I do the capital O underscore, capital I underscore. If it was an actual program, I'd probably do something like this. And then, maybe we have button 2 also, for whatever reason, does the solenoid. So we'll do, this is actually going to be, it's solenoid 1, but the second instance of it. So this should be the first instance of it. And then I would create another section of your program and call it, usually I do util, like a utility for I/O. And here you would do either of your solenoids will turn on your actual solenoid. So if you call this from either spot in the program, maybe you have a setup over here, maybe you have the main program over here, they both can control the solenoid. This is how you do the output. The other thing you might want to do is some solenoids, for instance, require one output to go high and one output to go low in order to actually charge the solenoid. In which case you could do this also from, something like this. So if, solenoid 1, maybe that's, maybe it's like an air blow. Air blow 1. So these you want to do the same thing, but air blow actually requires 2 solenoids. So then we can do solenoid 1 and at the same time, not solenoid 2. So now let's go online. All right, so when I hit my button, it switches the solenoids. I do this and it's back. So that's how you kind of can make it a little easier using the nomenclature in your program, but a util program to kind of do the work behind the scenes. Last thing, if you go to your, if you double click on the input or the output, but the input for the input, this is your debounce timer. So they call it a filter value setting. So we want it to read, the input needs to actually remain on for, say, 4 milliseconds before it registers as on. So this is to avoid those little like nuisance or noise you might be getting. And then this is to enable that debounce when going on or when going off. So if you need it to be on for, say, 4 milliseconds in order to turn on, and then you want it to remain off for 4 milliseconds to turn off, top option, this one, it'll go on immediately, but off requires 4 millisecond wait period.